Now Criterion C, processing and evaluating. So for the first part here, for the first strand, data collection and presentation, it says, includes formula and sample calculation, screenshot from Excel for any processing done, as an alternative, equation of the line and R-squared values displayed on the graph if appropriate. I don't care about these R-square values, to be honest, but the equation of the line I would like to be there. So let's have a look at what different people got here in these samples. So for the first one here, it says there's actually 6 different data points, but only one trial. And there's only one trial because there is the student got the same result every single time, and that is just because it's a simulation. Some simulations have a built-in error to make it more real. This one doesn't, so it's fine under these circumstances to just put one set of data in there. And then here the same thing again for the process data. You can also just leave it as it is. Here's a sample calculation. If you do a sample calculation, please do say what you're calculating. So this is meant to be the average temperature, and then say, well, either like this or say average capital T, and then say at the end what you actually found. So this would be 22 degrees Celsius. Okay, so much to the sample calculations. Then the graph says here the temperature and the seconds heated. This should actually be the time heated, in brackets seconds. That would be ideal. So let's have a look at what it says here. So choose the correct. Okay, I would say the graphs are well organized with descriptive titles, correct precision, and units. So the units here are not that well organized. It should be time and seconds, as I just said. But there is the equation of the line, so of the line of best fit. That is good. It's the right kind of graph. I would say this gets a 6 based on that, because some of the 7 to 8 aspects are included here. Let's have a look at the other samples of work. Here I have units inside the data. You do not want that. Please do always put the units into the header, as I said in one of my videos. And here it doesn't say what has been measured. This is the time in minutes, and that's what it should say at the top. And please don't put 1.45. I'm sure it's 1 minute and 42 seconds. So put a colon there, for example. And then it says here what the average is in seconds. The whole trial 1 to 5 could be left out, and it should say average time. Here again it should say average time in seconds, and you see what happens when you actually do it, that you put the units into the data. Then it can't give you a continuous x-axis. What you would want instead is something like this, and you see here it gives you a continuous x-axis, and these values that appear to be a bit random, like 1166 grams, they appear then here, and you have the values as vertical lines here that well, are rounded values and that you can easily deal with. Here you also can't actually get an equation for the line of best fit. That's important to remember. If you don't put in, if you put in the units here as well, the grams. So this one here would probably get, therefore, well, it's the right graph. I would say this gives something like a 3 to 4, because the units are not always in the headers correctly, and therefore you could argue that it's not arranged in a logical order. could be a bit more logical. So easy to improve on. Let's have a look at the last one. Here it says very nicely the amount of power in watts. There's the unit there. There's the final temperature in degrees Celsius, all very nicely recorded. The different trials are listed here. You could actually just reduce this to W, because if you don't write out the C for Celsius, in fact, just capital W looks even nicer than if you do it the other way. And then here you could leave out these three columns and just put the average temperature difference in. And then for the graph, let's have a look. So there's the equation, here's the temperature difference, here's the power, and there's a nice line of best fit. This all looks very neat and tidy. And here's the R² value, of which I said you don't need that actually. Here's a calculation on how to find the average. So this all looks very well done. And the finding the temperature difference, 20 minus the final temperature, okay, is shown here. Okay, it should actually be the other way around, final minus the initial, but never mind, the idea is correct. Okay, so I would say that this third investigation here would actually get a 7 to 8. Next one, data interpretation. It says for level 5 to 6 includes reference to R² value. That's basically a measure on how close the points are to each other. If you comment on that, I'm happy with that. That also means do you have any outliers? If they're too far apart, or some of them are, equation of the line, slope, range, qualitative observations as appropriate, and then it all has to be correct for it to be a 7 to 8. So let's have a look at what you get here in the different reports. So for the first one here, okay, it says a linear proportional relationship. What does this show? This shows actually 0.122 times x. So your temperature, the final temperature, is 0.122 times the time plus 14.1. 14.1 would be the y-intercept. That's basically, and you see that here, if you have a y-intercept that's not 0, then it's a linear relationship and not directly proportional. So this one here is a linear relationship, but not directly proportional. So this is not quite accurate. What is quite nice is the student has then calculated what the specific heat capacity is. In this case, it was a copper block. So if you have this sort of experiment here, where you heat a copper block, in fact, this is possible at school as well. We have the equipment for that. Then you can work out what the actual specific heat capacity of copper is based on your results. And this is quite close to the 385 that the textbook would state. Quite a good result. The one thing that you would definitely want is to put the unit in here. This is in joules per kilogram per Kelvin. Make sure that that is actually in there. Oops. And that you don't leave it blank. Wrong signs. There's a keyboard shortcut here for writing. There we go. If you press the command button on the Mac and the dot, the full stop or period, then you can actually write in superscript and with a comma in subscript. Okay, so that looks pretty good, and this would therefore get overall, yeah, this was okay. The label here is not, oh no, hang on, the label, we've dealt with that. Yeah, the proportional does not quite fit, but I would say overall Okay, there's no comment here on the equation. Well, no, there is a comment because the equation of the line is used to calculate the specific heat capacity. I would say this definitely gets a 6. I would be hesitant to go higher because of the mix up of directed proportional and linear. Let's have a look at the next example. You have here a direct relationship. There is no direct relationship. That doesn't say anything here. You would want to say it's either linear or directly proportional or something like that. So if you look at this, okay, there's an r squared value. Please, whenever you have something like this, do make the effort of actually putting in the superscript rather than writing it like that. The r squared value is surprisingly close to 1. Yeah, okay, but sadly, this doesn't quite make sense. And forget about the r squared value. Just comment on how close the data points are to the line of best fit. That will suffice. Linear trend line. Okay, does that make sense? Actually, you would expect a directly proportional relationship, and if you look at that same data, it is actually quite close. The y-intercept is only minus negative 2.11. That's quite close to the origin. So, but hang on, that is not very close to the origin, considering that it's actually the time in minutes, so it would be minus negative 2 minutes. That is not close to the origin at all under those circumstances. Actually, I was thinking seconds here. So that would leave us with the following. I would say this probably gets a 5. There's some understanding of a linear relationship that has been described correctly. There's a comment on the r squared value. There could be significantly more, so 5 would be the maximum that I would give for this. And the last one, let's have a look at what it says here. For the last one, positive linear relationship. This is actually very close to a directly proportional relationship because it really seems to go through the origin, and the y-intercept is 9.64 e negative 2. That means 0.0964, and on this scale here, that would actually be very close to 0. Okay, and there's a comment in here on this fact, so that it's quite close to being directly proportional. And let's have a look if there's any other calculation. Oh yeah, and then there's the calculation of the specific heat capacity that has been done here. And you see that there's a comparison as well to the specific heat capacity of, I think this was aluminium, if I'm not mistaken. Yes, aluminium is what we're talking about here. So this has been very nicely done. Just one minor thing would be, it shouldn't be joules per gram, but it should be joules per gram per degree Celsius, or actually, I think this should even be in joules per kilograms per degree Celsius. You could even write it like this. All right. Nevertheless, this actually ticks a lot of boxes. So I would say that this will be in the 7 to 8 range. Evaluating the hypothesis, let's have a look at that. So hypothesis, It says here for student 1, I predict that there will be a directly proportional relationship. Yeah, restated the hypothesis and is not directly proportional. Okay, and that is correctly said, actually. So this is a good observation. In fact, there was a mistake in the prediction, in the hypothesis. The hypothesis talks about the change in temperature, and I think this is just the final temperature rather than the change in temperature as such. So there was that mistake made here. That's where this came from. But the statement here is correct. So let's have a look. It doesn't say much more than that. I would say this is a 4, maybe a 5. It's certainly a correct observation. Next student, validity of the hypothesis, also kept very, very brief. Okay, if you see here, it says that there is a directly proportional relationship, but the graph does not show that. There's no formula shown here, no equation, and so it is hard to gauge whether this graph would actually indeed go through the origin or not. If the origin had been included, well, still with the units being part of this, you can't really tell, but then at least you would get a bit of a better idea. Here, this one tells us that the origin is definitely not included. So let's have a look at the next one. The and here we have the validity of the hypothesis. Okay, there's a comment on the R2 value, or R squared value rather. And then there is comment on slight outliers. That is good. Okay, if there's anything that could be done better, it would be to reduce a bit the amount of writing and to make it more concise. And yeah, the graph does look pretty much directly proportional, and that has been said. So without looking at this for even more time, I would say that this will probably be in the range of 7 to 8. So evaluating the method, there are 2 things left: evaluating the method and then improvement and extensions. Let's have a look at the first one. Evaluating the method, validity of the method. Since I use only, the first student says, since I only use, okay, this is very short. Of course, there can't be much said here because if you use a simulation, then you can't actually get any error, so it's a bit hard to talk about the validity of the method. Still, there could be a comment actually in terms of the calculated specific heat capacity, and that it is a little bit off. That would be good in this context. Let's have a look at the next one. Validity of the method. And the validity of the method here says is valid because the tools that are used to measure and control the variable work in a way that help to structure it. Okay, 5 trials. Good, that's useful to put something like that in there. The conditions were fair as I used the same kettle and kept the starting temperature of the water the same. That's also good. So there are some things that have been mentioned here. I would say evaluating the method probably comes in here under 3 to 4 for the second student. For the first student, okay, it's a bit hard to gauge this one. When you're doing chemistry, you'll probably do it on a real life experiment, and then it's a bit different than this. It's a bit hard to gauge where to place this first one here. It would be nice to have some more comments in terms of what is mentioned here. Let's have a look at the last one, validity of the method. Okay, this is more than I want to actually read out to you or for you to read through in detail now. Very thoroughly done, clearly. Let's have a look. There are some weaknesses identified, or just in general, the change of the voltage, for example, which meant change of the power. I'm just reading here. And then there's a number of different things that have been mentioned. Okay, overall this looks like very, very thoroughly done. This probably gets in the 7 to 8 range here without now going into the detail of this. Last one, for improvements. I like improvements to be actually quite realistic. They can be very simple. So for the first one here, okay, with these extensions, I always find them a little bit tricky to gauge. Suggestions for improvements due to the reasons above can't be given. Okay, but what could be said would be that here you clearly have a different specific heat capacity than expected. So it might be worthwhile actually doing still more experiments or collecting more data. The data could also be a little bit closer to the line of best fit. I don't know if what was described here was really true, that they were exactly in the right, well, that you would always get exactly the same results. Never mind. Let's have a look at these ones here, also very brief. Different masses of water. Yeah, that's a good idea. Only 4 data points. That's a bit too little. 5 would be the minimum, I would say. But it doesn't really go into much detail. So for this one here, I would say it's somewhere 2 to 3. I wouldn't give more than that for these improvements. And for the last one here, again, this person has obviously really gone to town, and I would now check, is this realistic, and read through this in detail and see what this should be awarded. From a first glance, I would say, let me have a quick look. Okay, also this student here is struggling to actually come up with realistic improvements, since this was done virtually. But just judging by what they've written so far, it seems that they've really thought about it quite hard, and this will probably be in the range of 5 to 6, if not 7 to 8, really. Okay, this just to get a bit of an idea of what the expectations are and how I would be grading this, so that you can actually gauge where your own work is at.